In this video, we're going to introduce relative change or relative percent change, and because it's important. So let's take a look at our example we had before. So my weight in pounds is given by this function, where t is in months. So example, January 1st, t is 1. So if you remember, this is our graph before. And so as I move along through the year, so the fourth month, April, I should be 222.5 pounds because I'm losing weight for summer. But then in summertime, I start eating again all the way back to December. So it's my weight as I fluctuate through everything. So what is my weight on January 1st? So if we move this to January 1st, that's 1 for January. 1 is January 1st month. That's December. 229.33. So 229.33 pounds. And so I can also just plug that in there. That's really just W of 1. So if I plug 1 into that function, you can see I get 229.33 pounds. So now what is W prime? Because we're going to be using the derivative to do all of our approximations. So W prime equals 225 would be 0. Cosine is going to give us a negative sign of pi over 6t. And then we have to apply chain rule, so that would be pi over 6. So again, this is negative 5 pi over 6 sine of pi over 6t. And so again, this is our dw over dt. And our units for w are in pounds. And our units for time is in months. And so this would become dw over dt, which is going to be the change in weight, so pounds, over the change in time, which is months, so pounds per month. So what is the approximate rate of change in weight on January 1st? So if I take my dw prime and plug in 1, it's going to tell me my approximate rate of change in weight on January 1st. So negative 5 pi over 6. What it'll actually do is tell me what my approximate rate of change is. Plugging in 1 gives me negative 1.309. And by putting units on it, it tells us what it means. So that's pounds per month. So it's saying on January 1st, I should lose 1.309 pounds for the next month. So within 1 month, so from January 1st to February 1st, I should expect to lose 1.309 pounds. So what would you expect my weight change to be for the next month? A loss of 1.309 pounds. See, there's no more months anymore because it's just the change. So the two questions are W prime is giving us our rate, so minus 1.309 pounds per month. And when I asked what would you expect my change in weight to be, I'm just asking for my change in weight, which is approximated by dw. In this case, it's our dy, right? It's our y value. Okay, so here is the new part. What is the relative change and percent change for the next 1 month? That's a typo, and I don't have time to go back and change it, so we're just going to change it right now to 1 month. So what is the relative change and percent change for the next month? So we know that my weight change will be minus 1.309. And my weight is currently in January 1st, 229.3. So if we want the relative change, then what we're looking for is your dy over your f of x. So in this case, what we're looking for is dw over our w. And we want to know what it is at 1 for each of them. You have to start with the same month. So what is my weight at that time, and how much do you expect me to change? So my current weight on January 1st is 229.33. And my expected change is 1.309. So that comes out to be negative 0.0057. See, what this represents is it's not that big of an issue. And so what we do now is just we make a percent change. And percent change just means make it into a percent. Because we like percentages because they tell us a lot more about it. So to make it a percent, you just multiply it by 100. or you move the decimal twice. So over 2. So this would become negative 0.57%. So it's not even 0.5% of my weight that I'm going to lose. So it's not a big change. It's not unhealthy. That's where it comes in. If this had come out to be 20% and then I lost 20% in a month, that would be not a good idea. That would be very, very unhealthy. So I'm at 229 pounds. That'd be like me losing 50 pounds in a month. Something went wrong if that happened. So when you have changes, you also want to look for relative change, and you want to change it into percent change to see if it makes a big difference. So we're going to be talking about error as well. So if you're making something and the error comes out to be, oh, it's off by 20 inches, but we're talking about 400 miles, then you've got a very, very small error. But if it's off by 20 inches and the thing is only 40 inches, you're off by 50%. That's a huge error. So these relative change and relative error, or percent change and percent error, tell us a lot about our actual change. And so that's where they come into importance. So the next video, we're going to do another example of how we can use this.